Exponential growth. So in exponential growth, right, so let's look at to draw it. This is kind of the general graph, right? So as we go left to right, that's how we're going to read it. So when the y values, what happens to the y values? Well, when x increases, right, so that means when we're going to the right, what happens to the y values? Well, that's also going to increase, right? Because it's positive. So y values increase as the x increases. This is just a visual to see why. Now, we're going to look at a general equation here. So this is our exponential growth. Can we also show decay? But this one, we're just going to look at growth for now. So what does a to the t mean? Well, that's just the amount at a given time. So this can be in years, months, days, whatever that is. It's a given amount, right? And then a subset 0, or O, this is our starting amount. So what did we start with? And then over so much time, we get to a different amount, right? And so how we get there is we have the starting amount times this E. So E is like a really, it's a number. It's really just like 2.718. And it can kind of continue on for all these digits, like infinite digits, kind of like pi. Or just like pi. Now, this is considered Euler's number. This is a really important number. It's going to show up all over math, right? Like physics, chemistry, all those different things, right? It's a really important number. So we have Euler's number. So it's kind of, you have it on a calculator, so it gives us all the infinite digits, or this is kind of the first 3 digits right here. Then we have K. Well, K is our constant. So what happens is we're going to have a growth constant here that's specific to the substance, right? And then T is given our time. So we have a constant, which will always stay the same for this, and then time will vary based upon the given time. So that is what those are. This is E. So now let's go over some examples. So example 1, a lab bought 3 mice. In 4 months, there's 108 mice. Assume growth will continue at this rate. So we're going to use our exponential growth equation. And so what we're going to do is we're going to find the k value. So this is going to be important for this, right, to find out everything else. So the k value is kind of really important. So that's what we're going to solve for first. So let's see what we have to solve for it first. So we have our starting amount of 3 mice, and then after 4 months, we got 108 mice. So that's actually a lot of information there. So let's go ahead and write that out. So this is for part A, right? So we have 108 mice show up, right, after 4 months. We have 3 mice. Then we're going to keep our E, and then we have K, which is what we're trying to find, and then our time, which is going to be 4. So we plugged in all our numbers, so now we need to find K. So first thing we're going to do is we're going to get rid of this 3 here. We're going to divide by 3 on both sides. So 108 divided by 3 it's 36. Then we have E raised to the 4K. So I just put the 4 in front. Now this is kind of the cool thing. So when we take the natural log on both sides, because whatever we do to one side, we do to the other. So we take the natural log of E to the 4K. Well, when we do that, what does this actually mean? Well, it actually means if we're going to, the left-hand side will stay the same. But this is equal to, what happens is this is going to go right in front. We're going to multiply this by ln, so the natural log of E. Then this is really important. This just becomes 1. The natural log of E is 1. So you can go ahead and type that in, take the natural log of E, that equals 1. So now we're left with just 4K on one side. So what do we do to that side? We just go ahead and divide by 4 on both sides, and we get our k value. So this is our k value. And we can look at that, what's that decimal number? So let's get our calculators out. So what we're going to do, so my calculator wants me to go 36, then take the natural log. Sometimes you have to do the natural log and then the number. So it depends on your calculator. Always ask your instructor if you need help. So we have the natural log of 36. Let's go ahead and divide it by the 4, and we get 0.8959. So we're going to round to 4 decimals. So this is our answer for part A. Now let's go ahead and solve for part B. So what we're doing is we're going to find out how many mice I will have in 9 months. So what we're doing is actually we're going to solve for we're going to plug in when t is equal to 9. So we have still the same starting amount, that doesn't change, e raised to, now we can put our k value in, so we're going to use the 4 decimals. And you can go ahead and do that in WAMAP, just use whatever decimals it tells you and just use that number, so you don't have to use that long decimal number. And then we're going to put in 9 for t, so we're multiplying those two numbers together. So this is just going to give us a number. So let's get our calculators out. So we have 3 times e, which is going to be, so for this one, what I'm going to do, let's move this a little bit so we can see what we're doing exactly. So I'm going to type in the 0.8959. I'm going to times it by 9, so we get that. What it's raised to for the exponent is equal to 8.0631. Then, so the natural log, so if we take the inverse of the natural log, that will be e to the x. So we're going to do that. So we take e, and we're going to take the exponent of that. So what happens is it wants me to put in the exponent and then put in e, so it shows me what that is. So we get 3,175. Then we're going to times it by 3. And what do we get? We get 9,525. So we're just going to round to the nearest whole number because we're looking at number of mice. So let's look at whole number. So 9525. And that's mice. And then let's look at part C. Let's do a different color. Let's go ahead and use black because we haven't used black yet. So when will the population of mice be? 1,200. So that means we're looking at 1,200. We still have the same starting amount. We have E. We still have our K value, right, of 0.8959. That doesn't change at all now. And then we're looking at T. What is T when that is equal to 1,200? So let's go ahead and, kind of like in the first part A, we're going to do this. Divide by 3 on both sides. So then we get 400 is equal to E raised to this 0.8959T. Okay, then we have to take the natural log of 400, and then we take the natural log of E to the 0.8959T. So what does that really mean? We get 0.8959T, natural log of E. This is just equal to 1 then. So we're multiplying those together. Then all we do is we go ahead and divide on both sides our K value. And then we get what T is equal to this. So let's go ahead and get our calculators out. So we take 400, take the natural log of that, then we're going to go ahead and divide by 0.8959, and we get 6.69. And what is that in? Well, we're looking at months for this one. So now let's do another example.